What I want to talk to you about in this video and show you is how we're going to try to find the general trend of data here. And I want you to really be mindful of, as we're looking for a line to describe how this trend behaves, is that we're not going to think about trying to include all of the data or know that we're going to have the exact equation that would be able to give us any future point without having to process anything. So it just gives us sort of an estimated sense of how does this behave if we were to create a model to describe it, what are the limitations of that, but also what are the benefits, because they're pretty fantastic. So the first thing I'm going to just ask you to look at here is that I have the price of gas, which is totally made up, and that we have the days at the bottom. I did weekly intervals from June 1st. Later in the week, we'll be using actual data through this week and next week, and we'll be modeling this, so I think that will be pretty great for you. And later on, you'll start your own project where you pick your own set of data to do the same. So let's just take a look at this. Like, we can see that there are certain times when it spiked, and then it fell, and then it rose again pretty steadily, spiked again, and then came back down. So what I would say is we'll start this tomorrow, but we're going to use a line to help us model this, because it does sort of it's relatively linear. Is there a line to describe all these points? No, but it's relatively linear. So what I'm going to do is I'm going to put a line here. Let's put a little line here first. Okay, so this line right here goes through a lot of points actually. And I think we can say that this is a pretty poor line because it is my predicted values along this line oftentimes fall short of what the actual values are. So I've underestimated. Like all these data points here are underestimated, and there's nothing that's been overestimated, right? Like if I say on August 10th, my predicted line, or based on my prediction, it would be about $3.55. It's a little bit lower than what it actually was of $3.60. But the same thing happens again here, where if I predict on June 15th, I'm predicting maybe $3.18, and it was really $3.55. And that happens every single time. The actual data point is higher than what the predicted value is. I want to try to balance that out. I want to be able to say that what I underestimated by, I balanced with what I overestimated by. So here I'm going to just sort of do a little bit of tweaking. This is a lot of tweaking, but you guys can handle this. So here's an example where I'd say pretty much the points, like here I've overestimated, and then here I've underestimated. And upon looking at it with just that criteria, this is okay, because the amount that I've underestimated by is balanced by what I've overestimated by, where the distance below the line cancels out with the total distances above the line. But this is a nice horizontal line, so I could say the equation here is y equals $3.70. Or 65 cents, I'm sorry, $3.65. This gives me absolutely no information. This would just tell me over time, like over the summer into the fall, gas just stayed the same price, which really is meaningless. So this line at best fit is terrible because it doesn't actually give any sense of prediction or change. This one also is poor, if I do say so myself, because I've underestimated every single time rather than balancing out what I've underestimated by with what I've overestimated by. Or my total distance above is canceling out my total distance below. So here I've canceled out the total distance, but again, really not very helpful or meaningful. And you can see that the general trend of the data is following this sort of slope. So what we would try to do instead is maybe have a line like this, so that my points here are going to be canceled out with my points here and here. Or maybe some of you would want it even to be a little bit less steep, so that the points here are canceling out there. Also in this way, if you think back to what you remember about median back in 7th grade when you're finding the midpoint of a set of data, is that you're canceling out the effects of outliers. So times when the gas was really inexpensive compared to when it was much more expensive, is that you're eliminating that impact on the overall set of data. which I think is really important. So at this point here, I can say that this is pretty good. And some of you might totally disagree with me, and that's what's beautiful about this whole unit, is that we can have multiple answers that are very appropriate and helpful. Okay, and I would say accurate. It's hard to use the word correct because there's so many right answers. So maybe something like this, although I would say the distance here is a lot less than the distance here, so maybe even up a little bit more. So that would be another one that would be fine, or something like this. What we're going to do is practice over the next set of days just finding the equation of this line, creating this line first, and then finding the equation for it. What I think you're going to find really pretty nicely is that the point slope form is huge for us in this situation. So if I were to take this here, and I'm going to use a colored pencil here, just a different color. So if I were to say that we're going to go with this line here, we'll see how this goes. I'm just going to hope that we go through two integer points at some point. Okay. So now what I would do to find the equation of this line is I would find 2 points that are on the line, and those are not necessarily data points. Like this here is not a data point, but it's a point on my line. So I have a point, and then I just need to be able to get enough information to get a slope. So I'm going to just use a different colored pencil to get the slope, to see a slope triangle. So I feel like this looks like a slope triangle here. Oops, sorry, I went off there. So I can say my slope is, my rise is 1, 2, 3, 4, 5, 6. And my run is 2, 4, 6, 8, 9. So I could say that my slope is 6 over 9 or 2 over 3. I can say that my point here is 824, right? And it is at $3.70. So the 370 is good for me to deal with. In terms of the x values, what I think are helpful is to just rename these and call this week 1, 2, 3, 4, 5, etc. So we can get out to here. So I have 2, 4, 6, 8, 10, 12, 13. So week 13, we're at $3.70 for what I would predict it to be. And now I can just write my equation. Y minus 3.70 equals 2/3 times x minus 13. I can solve it, find the y-intercept. I can approximate and see where that is here. But what we'll do tomorrow is just like this, is we're going to be able to we're going to play with lots of different lines that you might feel like are okay, and then you're going to get pushback from me and your classmates. You'll work with a partner. Then we'll talk about all that. After that, then you'll be able to identify the slope and then a point and then an equation of that line to describe it. And then you'll talk a lot about what the slope means. So for this here, I'd say my slope of 2/3 means that for every 3 weeks that go by, I'm going up 2 of these jumps. So that means 10 cents for me here because I did intervals of nickels, or 5 cents at a time. So I hope this has been helpful, and then tomorrow in class we'll just go through the same thing again. Thank you.